Now we know when we do the drawing, it's got to include two parts to it. The drawing has to include an inside part that we call the nucleus, and it has to include an outside part that we call the electron cloud. We're finding out that the nucleus is just essentially one area of space, right at the inside of the atom. But the outside is broken up into different areas of space, different what we're going to call energy levels. And the periodic table shows us not only how many protons and electrons the atom has, but obviously where those protons are in the nucleus, and more importantly, where those electrons are and how they're distributed throughout the different energy levels. So, when I pick number 20 calcium to draw number 20 calcium, what I would do, you don't need to draw this, what I would do is I would start out by drawing the nucleus. 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And I would start out by drawing 20 protons in the nucleus. You don't need to draw this. You just kind of watch right now. We're just doing a review. So 20 protons in the nucleus. Now, if we were to take a piece of matter, whether it's the desk or the table or you or the grass outside, and shake it apart to its individual atom and zoom in on one individual atom, it would not have a little sign hanging here saying this is the nucleus. It's just an area of space where this is located. Do you mind making sure the door closes? Never mind. This is just an area of space. It's okay. This is just an area of space that we call the inside part of that, and we're going to call it the nucleus. Now, that's the easy part because there's just one space. There's one area that we call the nucleus. The second part is a little bit more difficult. The second part is the outside of the atom, and it is broken up into different areas of space. And the way we know what that area of space looks like is based off the row that that element is in on the periodic table. So very quickly, we can determine a lot of information just by the space or the area that that element is in. So immediately when we slide sideways, we see that that calcium is in energy level number 4. It's in row number 4. Yesterday in red, we identified on our big periodic table the energy levels. And if you look at the back side of your whiteboard, what they do is they also have it listed there with energy levels. The biggest atom we will ever have will have 7 energy levels. That's the most you can get. Correct. So, here, what I would do is I would draw energy level number 1, energy level number 2, energy level number 3, and energy level number 4. The outside of the atom is broken up into different areas of space, different energy levels. Now, what we need to do is determine how we put those 20 electrons. We know there's 20 protons in the nucleus and 20 electrons arranged outside the nucleus. We need to determine how those electrons are arranged outside the nucleus. What we're going to do to figure this out is walk through the periodic table. So we're trying to end up at the element of calcium right here. So we always start with element number 1. So we start with hydrogen. So in energy level number 1, in this first energy level, we slide over and we count 1 for hydrogen and 2 for helium. So in that first energy level, because that's energy level 1, I'm going to put 2 electrons in. Then I slide down to energy level number 2. Now we're talking about energy level number 2 here, and we count over. 1, 2, 3, 4, 5, 6, 7, 8. 8 across row number 2, energy level number 2. So I count 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons in energy level number 2. Then I go down to sodium because I've already counted through row number 2. Down to sodium, energy level number 3, and I count over. 1, 2, 3, 4, 5, 6, 7, 8. So once again, in energy level number 3, we've got 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons in energy level number 3. And then finally, I get to energy level number 4, which is the last energy level, and I count over 1, 2. 2 spots, so that means on the very outside of calcium, there will be 2 electrons. what I want you to notice is we could start doing a shortcut and not actually counting through the whole periodic table and figuring out a lot of information just by the location of the element. Because we see a 4 here, we know immediately there are 4 energy levels. But also on the top of calcium, up at the top there's a big 2A, which means on the outside of calcium there are 2 electrons. We have 3 names that we'll use for these electrons. The best name we could use is the number of electrons available for bonding. Those are called the bonding electrons. We just found out from our definitions, instead of bonding electrons, we can also call them valence electrons, and sometimes I will call them the outer electrons. I will use those 3 interchangeably all semester long. Sometimes I'll say the outer electrons, and you know, oh, the outside. Sometimes I will say the valence electrons, you know, oh, the outside. Sometimes I will say the bonding electrons, and say, oh, the outside. Those are the most important because as this atom flies around and interacts or collides with other atoms, it's the outside of the atom that's doing this, not the inside.
Just those 2?
For this atom, just those 2. So if you were looking for something similar among atoms, you would say, hey, lithium, sodium, and potassium, all in column 1A, all have 1 electron on the outside. And everybody in column 2A all have 2 electrons on the outside. And that will make them behave similarly because when another atom approaches calcium, all it sees is 2 electrons on the outside. Or when it approaches magnesium, all it will see is 2 electrons on the outside. So all the atoms in the same column behave similarly and have similar properties. And so, as we go through this, pretty soon we're going to come up with shortcuts so we don't have to draw this whole atom out. But right now, I mean, as soon as you see potassium, oh, 4 red rings, but only 1 electron on the outside. Or if we went over to, like, gallium, in someone in column 3A, oh, 4 red rings, 4 energy levels, 3 electrons on the outside. And so real quickly, just based off its position on the periodic table, we can get an immense amount of information about that atom. Okay?